Hey everyone, Mr. Hauk here. In today's video, we're going to be deriving the formula for the area of a triangle, using those formulas to calculate the area of triangles, and using something called Heron's Formula to solve for the area of a triangle as well. So, remember back to geometry, where you learned that the area of a triangle is 1/2 base times height, or you have this formula here, area equals 1/2 BH, where B represents the base and H represents the height. So, we want to derive the formula for the area of a triangle such that we actually don't need to know this h right here. And what we're going to do is let's construct an altitude h from angle B to side B, which would be right here. Okay? Well, if we look at this altitude, if we took the sine of angle C, well, we know sine is opposite over hypotenuse, so the sine of angle C would be h, the opposite leg, divided by a, which would be the hypotenuse for this right triangle. So this is what we would end up getting. Sine of angle C equals h divided by a. Well, if we look at that and we multiply both sides by a to solve for h, we get that h equals a times the sine of C. The reason that I want to isolate for h is because now I can take what we know h to be and we can plug it into the area formula, and it's actually going to give us an equation in which we don't need to know the height h, in this case h being the altitude. So let's go ahead and do that. Area of a triangle is 1/2 base times height. We're going to replace h with a times the sine of C, and that's going to give us that the area equals 1/2 b times a times the sine of angle C. Rearranging that, we get that the area of the triangle is 1/2 AB times the sine of angle C. And it turns out this is only one of 3 different area formulas. So we can actually have 1/2 AB times the sine of angle C, 1/2 AC times the sine of angle B, or 1/2 BC times the sine of angle A. And what it all actually boils down to, and I put a little red note here, try to make it stand out as much as possible, but these are all actually side angle side pieces of information. So what that means is when we have a triangle and we know 2 sides in the included angle, we can always calculate the area of the triangle. And if you don't believe me, take a look at these 3 area equations. The first one says 1/2 AB times the sine of angle C. Well, if we look at our triangle, here's side A, here's side B. The included angle is angle C. Here's AC, side A, side C. The included angle, angle B. And then also finally, here's side B, here's side C. Included angle, angle A. So again, if you have 2 sides and the included angle, you can use these formulas or these equations to calculate the area of that triangle. Now let's see some of these examples kind of worked out. So our goal is for each one of these problems, in order to calculate the area of these triangles, we need to find out, or at least work the problem to a point to where we have 2 sides and an included angle. Notice that for our very first triangle, we actually fall right into that scenario. We have side, side, here's the included angle. So since we have side angle side to start with, the area calculation is very easy. It's 1/2 times the 2 sides that we have, 12 and 15, multiplied by the sine of the angle that's in between them. So the area is 1/2 times 12 times 15 times the sine of 34 degrees. This is going to give us that the area is 50.3 feet squared. We're going to say feet squared because feet is the unit, and we know area is units squared. Okay, so that one's pretty easy. So when you run into that side angle side scenario right from the beginning, things are nice and simple. But you're not always going to run into that scenario. So take, for example, the next problem. Notice that now we have an angle, and a side. So we do not have side angle side yet. What we need to do is work through the problem to a point to where we can get side angle side. So the first thing that jumps out to me, well, if I can get this side right here, which would be side F, then I would have side F, side D, and the angle in between them. So if I want to find side F, then I want to find angle F and then use the law of sines to find side F. So measure of angle F is going to be 180 degrees minus these two angles. It's going to give us 46 degrees. So now we have all the angles. Next, I'm going to set up the law of sines, and I'm going to say the sine of 49 degrees over 6 equals the sine of 46 degrees over side F. Cross multiplying and solving for F, we get that F is 5.7 inches. Now notice that I am at the point where I have a side angle side triangle, or at least I have two sides and an included angle. I have side here, 5.7 inches, this side here, 6 inches, and most importantly, I have the angle that's in between those two sides, which is 85 degrees. So now we have side angle side. So the area of this triangle is going to be 1/2 times those two sides multiplied by the sine of the angle in between them. So notice we're using the information that makes up the side angle side. So we're ignoring the 46 degrees for the area calculation. We're ignoring the 49 degrees. These two are irrelevant to the calculation. We just want the side angle side when we make the area calculation. And then we're going to get, once you plug that into a calculator, that the area is 17 inches squared. Okay, it's not that bad. Example 3. This time we have an angle side angle. Again, that's not SAS, that's not side angle side. So kind of thinking through this problem, I might want to do something very similar. I want to go ahead and find angle P, because once I have angle P, well, my goal is if I can get angle P, then that's going to help me use law of sines to find side Q. And if I can find side Q, then I'll have a side angle side, and that's going to allow me to calculate the area of the triangle. So first step, measure of angle P, 180 degrees minus these two angles right here. That's going to give us that the measure of angle P is 18 degrees. Now that I know that the measure of angle P is 18 degrees, let's use the law of sines to find side Q. So the sine of 18 degrees divided by the side across from it, 4, is equal to the sine of 67 degrees divided by the side across from it, which is Q. Of course, we're searching for that, so it's going to be Q in our equation. Cross multiplying and solving, we get that Q is 11.9 miles. Okay, now notice at this point we do have side angle side. We have side 4, side 11.9, the angle between them 95 degrees, so we do have side angle side now. So we can calculate the area as 1/2 those two sides multiplied together, 4 times 11.9, times the sine of the angle that's in between them, sine of 95 degrees. This gives us that the area of this triangle is 23.7 miles squared. All right, in our fourth example, now we have side-side angle, but what's important to note is that this angle is not an included angle. It's not the angle between the two sides. So we still don't have side angle side. We have side-side angle. So again, we want to think, what do we need to do to get to a side angle side scenario? Well, what I'm thinking is if we can get angle T, then we'll have side angle side. So the first thing that I'm going to do is I'm going to go ahead and try to find angle R. Because if I can find angle R, then I can take angle R, angle S, subtract them from 180, that gets me angle T, then I'll have side angle side. So I set up the law of sine equation, sine of 110 over 10 equals sine of angle R over 5. This is going to help me calculate angle R. Cross multiplying and solving, we get that angle R is 28 degrees. Now that we know that angle R is 28 degrees, that means angle T has to be 180 degrees minus these two angles right here. And that gives us that angle T is 42 degrees. And now that we know angle T is 42 degrees, we now have a side, and the included angle. So the area of the triangle is going to be 1/2 these two sides multiplied together times the sine of the angle in between them, 42 degrees. And that's going to give us that the area of this triangle is 16.7 yards squared. Now, what I tried to do here for these 4 examples is give you examples of 4 different kinds of triangles. We had a side, angle, side. We had an angle, angle, side. We had an angle, side, angle. And we had a side, side angle. The one type that we didn't look at is a side, side, side triangle. And we saved that for last because there's actually a special formula that we can use called Heron's Formula when dealing with side, side, side triangles. So I'm not going to go through and derive Heron's Formula, but I have left a link right here. If you go to mathworld.wolfram.com, right here, you can actually see more than one proof or more than one derivation of Heron's Formula. But what it turns out is that when you have a triangle and you're given all 3 sides, or if you can find all 3 sides of the triangle, then you can actually use a special formula right here to calculate the area of that triangle. So Heron's formula says the area is equal to the square root of s times s minus a times s minus b times s minus c. Now we know a, b, and c, or lowercase a, b, and c, those just represent the sides of the triangles. But this s is new to us. We haven't used s before, or we haven't identified a variable s. Well, s is something called the semi-perimeter of the triangle. And all semi-perimeter means is if we take the perimeter and we cut it in half. And we, of course, know that the perimeter is what happens when you add up all the sides of the triangle, or just in general, all the sides of a figure. So what this is telling us is, according to Heron's formula, the area of a triangle is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. Let's see this in action here. So in our 5th and final example for the notes, we have a side, side, side triangle. Let's go ahead and use Heron's formula. The first thing we want to do is calculate the semi-perimeter. And the semi-perimeter S is going to be the sum of all the sides, the perimeter, 16 plus 11.2 plus 16 divided by 2. That's going to give us a semi-perimeter of 21.6. Once I know the semi-perimeter, it's a pretty easy calculation. It's just going to be the square root of the semi-perimeter, 21.6, times the semi-perimeter minus one side, times the semi-perimeter minus the next side, times the semi-perimeter minus the final side. Plug all that into the calculator, and we get that the area of this triangle is 83.9 yards squared. So that's Heron's formula. Heron's formula is great when you know all 3 sides of a triangle. And then, of course, when you have other types of triangles like examples 1 through 4, then you're going to use these formulas right here. And again, the most important part is when calculating the area of these triangles, make sure you get yourself into a position where you know 2 sides and the included angle. Then you're good to go.